Your number is actually that number is saved like two-way student because there are many students. Okay, your number is saved with Srishti, but ma'am's number is saved with Dubai student. Got it or not? That I will say save it today. Okay. Okay, so let us just start it. So till yesterday, what we did, like day before yesterday, I think so. We completed till over here, isn't it? Like writing the kinetic energy and potential energy equations and all these kind of things, isn't it? Yeah, so phasor diagrams, kinetic energy, and all these things were completed. So today we are going to start with see, as we were able to write the time period equation, as we were able to write all these kinds of equations. Now we'll move on to something which we call it as writing the wave equation, means angular frequency equation. Okay, so this is one of the most important things of this particular chapter or this particular topic. Okay, like how to determine the time period and angular frequency in simple harmonic motion. Is that clear or not? Okay, so we are going to start that and we'll try to understand how to do that and then we'll move ahead. Is that clear? So let us just, like, this is totally a new topic for you. The first thing is finding the time period. Okay, good evening, Riva. Okay, and then finding the angular frequency. Okay, so let us just first think of that. So you know that that time period and angular frequencies are interrelated with each other. Like omega is equal to 2 pi by, yeah, 2 pi by time period. Is that clear or not? This is my relation which we follow, and this relation actually provides us. This relation provides us the concept of total time period in case of SHM. Okay. Now the question arises that how to do this, how to do this calculation, how to find this total time period. Now, as we know that we have found out the energy equations, we got to know what is called as how to find the energy and all these kind of equations, isn't it? Now, the time period are calculated on two ways. On how many ways? Two ways. One is by the method of force equation. This time period of SHM is calculated in how many ways? Two ways. One is by the method of force equations. Okay. And another one is the energy equation. Is that clear or not? Basically, the force equation, we follow two different kinds of processes for all these kind of topics, like how to deal with force equation, how to deal with energy equations. Both are actually equivalent to each other. मतलब ऐसा नहीं है कि एक हार्ड है एक इजी है, ऐसा कुछ नहीं है, दोनों इजी ही है, दोनों हार्ड भी हैं. अगर तुमने कॉन्सेप्ट सही अप्लाई किया तो दोनों इजी हैं, तो अगर कॉन्सेप्ट सही अप्लाई नहीं किया तो दोनों कैसे हैं, हार्ड. इज दैट क्लियर और नॉट? So basically, we will go with the force equation first, means how to write the time period using force equation. Is that clear or not? T using force equation. You can prefer any case, whichever case you want to prefer, both are applicable. Is that clear or not? ठीक. So how to write it? First question is how to write it. Then let us just understand through a series of points the how to write it. Basically, the first step is followed. The first step is first write the mean position equation. क्या करना है? Write the mean position equation. Let's suppose just take an example of that. मान लो अगर तुम्हारे पास एक एसएचएम हो रहा है ना, और किस तरह की एसएचएम है? वर्टिकल एसएचएम. किस तरह की एसएचएम? मान लो इसके साथ अपन ने एक ब्लॉक अटैच कर दिया है ना. 1 minute, let me just attach a spring over here. Okay, so now you know that this block or whatsoever it is, ये पहले स्प्रिंग क्या होगा? ये यहाँ पे क्या है? नेचुरल लेंथ कंडीशन है ना. इसके बाद ये कहाँ पर एक्सटेंड होकर आएगा, एक ये ब्लॉक अपने इक्विलिब्रियम पॉइंट पर आएगा या नहीं आएगा, है ना। तो बेसिकली दिस ब्लॉक विल ट्रैवल सम डिस्टेंस, हाउ मच, एक्स नॉट, कितना डिस्टेंस ट्रैवल करेगा। So basically for this equilibrium point, as you know that this block is traveling some x naught distance. So this equilibrium point, or in another sense, we call this equilibrium point as what? Mean point. क्या बोलते हैं इसे अपन? Every equilibrium point is called as mean point. So we'll write the equation of equilibrium point with respect to mean point over there. Is that clear or not? Now, as you were, जैसे ही तुमने इक्विलिब्रियम पॉइंट या मीन पॉइंट का इक्वेशन लिख लिया, जैसे मान लो अगर ये इक्विलिब्रियम पॉइंट है, तो हमें मालूम है कि इक्विलिब्रियम के केस में जो ऊपर का स्प्रिंग फोर्स होगा बेटा, वो नीचे के वेट के, हाँ हाँ, तो स्प्रिंग फोर्स जो होगी वो mg के बराबर होगी, और यहाँ पर जो वेलोसिटी होगी वो जीरो नहीं बल्कि कैसी होगी, मैक्सिमम, कैसी होगी। Is that clear or not? So we will write the first step, which is the mean position equation. Writing spring force is equal to how much, mg. How much is that, mg. अब ध्यान से देखो, अगर ये डिस्प्लेसमेंट x नॉट का हुआ है, तो दैट मीन्स kx नॉट विच इज माई स्प्रिंग फोर्स, अगर स्प्रिंग कांस्टेंट इज k, देन kx नॉट मस्ट बी इक्वल टू हाउ मच, mg। क्या इसके बराबर होना चाहिए, बराबर, इट मस्ट बी इक्वल टू हाउ मच, mg। इज दैट क्लियर और नॉट? ठीक, yeah. So now this was my first step, writing which equation, equilibrium equation या mean point equation। ठीक, इसके बाद आता है स्टेप टू। क्या आता है स्टेप टू? दैट इज डिस्प्लेस द पार्टिकल। Step 2 is displace the particle from the equilibrium point by some distance x naught, by some distance x। अब क्या करो कि जो पार्टिकल दिया गया है, ठीक है ना, उस पार्टिकल को इक्विलिब्रियम पॉइंट से भी अब डिस्प्लेस करो। क्या करो, आफ्टर दिस यू स्टार्ट टू डिस्प्लेस द पार्टिकल फ्रॉम द which case equilibrium point। So now let us suppose if I just displace it, this particle will appear over here, isn't it? And from the equal natural length, this displacement will be something, let us just call this, that this displacement was given as y। क्या है ये, is that clear or not? Now if it is y distance, I call this from the equilibrium point, this is displaced by something, displacement of how much, x। x क्या है, displacement of block from equilibrium point, है ना। तो ध्यान से देखो, तीन चीजें हमें मालूम चली। पहली बात कि हमें पार्टिकल का इक्विलिब्रियम पॉइंट पता करना है। क्या पता करना है, इक्विलिब्रियम पॉइंट। जैसे ही तुम्हारे पास उसकी इक्विलिब्रियम पॉइंट आ गई, उसके बाद उसको और डिस्प्लेस करो बाय अ सर्टेन अमाउंट x, एंड देन राइट द इक्वेशन, देन राइट व्हिच इक्वेशन, द फोर्स इक्वेशन फॉर दिस लेंथ। क्या करो यहाँ पर, तो यहाँ पर जो स्प्रिंग, yes, so this spring force this time must be equal to how much? As you know that the body will have a tendency to go upwards, isn't it? At this point, the body has tendency to go where? Because here almost the velocity will be similar to zero. कैसा रहेगा velocity? Yeah. So basically, the force acts upward, and that is exactly equal to mg minus k spring force, which is x naught plus x। Are you able to get me or not? क्या क्या क्या? Is just why. Yes, there was a question from YouTube. Since we are pulling it down, is there will be any kind of external force? Riva, we are not pulling it down. The block is going by its own external force, which is mg. Is that clear or not? मेरी बातें समझ में आ रही है ना? हम इसको पुल करने की कोशिश नहीं कर रहे हैं, है ना? ये mg के वजह से ही नीचे जा रहा है। कहाँ जा रहा है? mg की वजह से नीचे जा रहा है। इज दैट क्लियर और नॉट? तो ध्यान से देखो, तो जो के एक्स नॉट है उसकी वैल्यू कितनी है? mg के बराबर है या नहीं है? तो ध्यान से देखा जाए तो इसकी जो फोर्स इक्वेशन आएगी वो क्या आएगी? एफ बराबर अपन ने लिखा था विच इज mg माइनस के एक्स नॉट प्लस एक्स। तो देन दिस के एक्स नॉट बराबर mg है, तो mg माइनस mg will be cancelled, minus kx, तो force will be equal to how much? Minus kx। क्या चीज के बराबर आएगा? Is that clear or not? And this is the force which we are finding out. This is the required result or condition for movement of block or SHM, or for the SHM। ठीक है? Is that clear? One minute. Yeah. रिवा इज आस्किंग mg के वजह से इक्विलिब्रियम पॉइंट अटेन करेगा ना? mg के वजह से ही इक्विलिब्रियम पॉइंट तो अटेन करेगा। इक्विलिब्रियम पॉइंट के बाद उस पॉइंट पे वेलोसिटी जीरो हो रही है क्या? नहीं ना। आई हैव मेड यू गाइस मेनी टाइम्स अंडरस्टैंड दैट एट इक्विलिब्रियम पॉइंट आई हैव v max, so this v max will become zero after some time or not, so till that spring force will act, no external force is required। is that clear or not? ठीक है ना? ये अपन ने पढ़ा था ना सृष्टि? हाँ, तो basically you just follow that previous lectures of spring forces and then you will get to know। okay, तो ध्यान से देखो, जो फोर्स है वो क्या चीज के बराबर है? माइनस ऑफ के एक्स। क्या चीज के बराबर है? तो बेसिकली या दिस इज माय फोर्स present at some displacement or not, and that too in which direction? That too in upward direction। F is equal to minus of, this is my net force which is present after displacing the particle by x distance, isn't it? Now we know that displacement of particle, अब हमें मालूम है कि जो एफ नेट होता है बेसिकली अकॉर्डिंग टू एस एच एम इक्वेशंस, ये इसका थर्ड स्टेप है ना? According to SHM equation, we know that force और जो भी है must be equal to F is equal to या acceleration is equal to minus of omega square x। क्या है? This is my SHM equation or not, which is minus of omega square x। Now, if as I know that SHM equation says that this is minus of omega square x and F net I am getting as minus of kx, so acceleration must be equal to, means this omega square must be equal to root under k by m or not, and that is my angular frequency। Are you able to get me? Now we know that as we know that angular frequency, if you are aware of angular frequency, which is root 1 minute, this will not be a square, okay? Omega is equal to root under k by m, so omega square I can write it as, and I know that this implies omega barabar root under k by m। Now omega is also equal to 2 pi by time period, so yeah, so basically the time period in this case of SHM must be given as T is equal to 1 by 2 pi root under m by k। K of which case? SHM case. Which case, guys? SHM. And this is how we find the time period of SHM। Are you able to get me or not? Yeah. following SHM equation. Are you able to get me or not? So what we got to know, let us just try to understand that how to find this. First step is write the equation for equilibrium point. Then write the slide means just try to displace the particle by a slight amount. Then write the force equation for that. Replace one of the term with the equilibrium point equation. You will get the net force equation. And in that net force equation, the K will represents the omega value. And that omega can provide us the time period. Is that clear or not? मेरी बातें समझ में आ रही हैं? अब जैसे मान लो, ध्यान से देखा जाए अगर, तो अगर मान लो कोई ऐसा सिस्टम है जैसे एक ब्लॉक दे दिया, उसको अपन ने स्प्रिंग से अटैच कर दिया है ना, and now on this block I apply a force if not towards the right direction. ठीक. Now the spring constant is K. The question is find the time period of SHM. Tell me what will be that equation. Hi Akhil. बताओ क्या होगा? What is the time period of SHM? अच्छा, यहाँ पे देखो वर्टिकल केस में था, पहले एक एक डिफरेंस समझो. Yeah, yeah. So in case of vertical, whenever there is a block that is pulled by some kind of force to till x, not till some distance x, where spring force balances mg, and that is called as equilibrium point, है ना? यहाँ पे कुछ अलग होगा सीन, है ना? अच्छा पहले एक बात बताओ, फर्स्ट ऑफ ऑल टेल मी, is this point a equilibrium point or not? Is it equilibrium? It's a natural length point. Equilibrium point means what? That the net force must be equal to how much? Zero. Is that clear or not? So basically, the question over here, it's not means it's too much easy, but the point is people does not understand about equilibrium and the point of नेचुरल लेंथ. अब ध्यान से देखो, एक ऐसा टाइम आएगा जहां पे स्प्रिंग स्ट्रेच होगा. क्या होगा? बाय दिस एक्सटर्नल फोर्स दिस स्प्रिंग विल बी स्ट्रेच्ड, and what will happen? This mass will be displaced by some amount. This mass will be displaced by some amount from its natural length point, isn't it? And over here another force must be present. एक ऐसा force होगा that will be must be present in opposite direction, which we call it as spring force. क्या बोलते हैं इसे अपन? And over here this spring force balances external force. If not, then we call this as equilibrium point. क्या बोलेंगे इस point को? So that point which we considered initially was not equilibrium point. This point is not an equilibrium point. Are you able to get me? Everyone? Yeah, this is a case of which kind of point? Natural length. Equilibrium point कहाँ है? जहाँ पे right force is equal to left force, upward force is equal to downward force. Are you able to get me or not? So once again at equilibrium point, spring F naught is exactly equal to how much? Kx naught. क्या इसके बराबर है? First step done means we wrote the equation of equilibrium point. Now from the equilibrium point, once again what we will do, we'll displace this particle by a certain amount, isn't it? Now we will displace the particle by some certain amount and the block will appear over here, isn't it? Yeah, we are extending it more. Now this was my natural length condition. From here I have displaced by some amount. Let us call this as y. क्या बोलेंगे? So from the equilibrium point, if I displace by a distance, how much? X. कितना displacement किया है अपन ने? X. So second step, X is my displacement from equilibrium point. Equilibrium point. Are you able to get me or not? Now here also the spring force is acting, but the spring force is much more greater in which direction? Backward direction. In which direction? So then once again, what will be F net equation? F net will be equal to F naught minus K x naught plus x or not, because this is the spring force which is present from the natural length. क्या चीज के थ्रू प्रेजेंट है? Is that clear or not? So did you got the idea that we do not, first of all, we have to remember that the spring force is not retained with respect to equilibrium point. Spring, this displacement x is measured from the natural length, while the equilibrium point is that point where the net force is basically how much? Zero. Are you able to get me or not? Now you know that kx naught is exactly equal to f naught. So once again, f naught is equal to how much? F net is equal to f naught minus kx, which gives me ultimately minus of kx. Once again, acceleration equation is same. A बराबर minus of omega square x, so omega बराबर root under k by m, which is equal to, this implies time period is equal to 1 by 2 pi root under m by k, and that's what is my time period of this SHM which the body is following. Are you able to get me or not? For the same formula we are getting for the horizontal and vertical. Nothing is changed basically. Over there was an external force mg. Now here is an external force F naught. तो इसका मतलब क्या मालूम चला? You got one conclusion. If there is one block, अगर ब्लॉक कैसा है? If there is one block of mass m attached directly with the string with spring, okay, of a spring constant k, then the time period is given by, अगर मान लो सब कुछ नॉर्मल है, अगर एक ब्लॉक है एक स्प्रिंग है, तो टाइम पीरियड का जो इक्वेशन होगा वो हरदम ही क्या होगा? 2 पाई रूट अंडर m by k. क्या होगा? 2 pi root under m by k. Means if there is only one block, is it 1 by 2 pi? Ah, 1 minute, 2 pi. 1 minute, let me just check. Uh, whoa, 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 whoa. No, 1 minute. If I am writing 1 by 2 pi, sorry, this is 2 pi root under m by k. Because if I just do the cross multiplication, are you able to get me or not? Sorry, that's frequency equation I was writing. So 2 pi root under m by k. Is that clear or not? So this is how much? 2 pi root under m by k. Means any kind of connection is there. Let's suppose I'll take an example of that. One of the best example is, let's suppose if there is an inclined plane. Which kind of plane? Of inclination, some kind of theta. And you just took one spring and attached to one of the blocks, okay, of mass m. Then once again here also the time period will be same, which is 2 pi root under m by k. Is that clear or not? Any kind of doubt till now? So if there is one block, one spring system, the time period is given by 2 pi root under m by k if all the conditions are normal. कैसा हो सारा condition? There is no such kind of G effective or such something like that. Is that clear? Basically, I can put this thing also in a lift or not. So then the value of G will change or not. Yeah, so that is why we are considering all the things to be normal. Means I'm just considering everything. Yes, just conservative forces. Is that clear or not? So let us just try to evaluate this for many kind of systems. And one of the system is given over here. What it is told that, let's suppose if I have a mass m, this is just did right now. I have a one block and one spring of spring constant. How much? K. Block कितना है? हाँ, तो इसका टाइम पीरियड की वैल्यू क्या आएगी? सिंपल सेम 2 pi root under m by k. Is that clear or not? Where omega will be given as just root under k by m. Are you able to get me? So if it is a one block, one spring system, the time period is very simple, which is 2 pi root under m by k. मेरी बात समझ में आई है नहीं है? ठीक है ना? So basically that's what we proved earlier for the vertical case, isn't it? Okay, so let us just try to see what will happen for the. This is one of the most important question. Like what will happen if you have an indirect connection? Indirect connection, like mass m is put it with the spring over a pulley, and then it is asking find the time period of mass m. Try to do it. Is it going to be same or different? Think. Riva, any kind of answer? Is it going to be same or different? This system right now once again it is not in equilibrium, it's at natural length. Every time you have to consider all the vertical cases, all the horizontal cases at natural length. Are you able to get me or not? Now you look over here, this system can be just, can I just make it horizontal? I'll since the string is one, since the string is only one, I can just consider that the spring is one. It is attached with the block of mass m. Is that clear or not? Pulled by a force how much? mg. क्या जिसके थ्रू pulled हो रहा है? Okay, I'll tell you the trick later. Let me prove it. I'm going to kill you God or not one day. That's so good. That's so true. Is that clear? Let me just do it. Try to see. अच्छा, this is natural length, isn't it? Yes. इसके बाद क्या होगा? ये इक्विलिब्रियम पॉइंट पे जाएगा ना? कितना डिस्टेंस ट्रैवल करेगा? x नॉट, और ये ब्लॉक कहाँ पर आया? इक्विलिब्रियम पॉइंट पे। तो जो भी यहाँ पे टेंशन होगा that must be exactly equal to the spring force or not, because spring force is basically fixed over here and the spring will be displaced by a same displacement x naught, है कि नहीं, है ना. तो spring force is once again exactly equal to how much, mg at equilibrium point, which is exactly equal to kx naught barabar how much, mg, because this is my condition for equilibrium point. Are you able to get me? Now from the equilibrium point it gets displaced by how much distance, x. So the spring will be also stretched by how much distance, x, isn't it? Yes, so basically F net equation will be what, similar, mg minus k x naught plus x or not. Spring force will be kx naught plus x, so mg minus kx naught plus x will be F net. So F net, hmm? That is minus kx, simple. So that means once again the answer is same. The time period is okay. So it is what, same. कैसा रहेगा हरदम? Same. Yes, Reva, it is correct. It is same. Are you able to get me or not? I can treat it like one block, one system. If the system is direct in nature, are you able to get me? Because even a tension force is similar with the spring force because both are the same kind of forces which are contact forces. What? I just said that since spring force is similar to tension force, क्या जिसके similar है ये? So that means it is same like just attaching one spring with one block. Are you able to get me? मतलब अगर इसको इसको दूसरा ट्रिक है कि मैं इसको क्या कर सकता हूँ कि पुली को हटा दूंगा, सिंस टेंशन इज सिमिलर टू स्प्रिंग, व्हाट आई विल डू इट, आई जस्ट रिमूव दिस पुली and can I just treat like one spring with the one block or not, simple, with the force mg towards, see, the pulley is a massless object or not over here, बात तो खत्म है ना फिर, can I just make it horizontal like this way, isn't it? Because pulley is frictionless and massless, so this string, this length of the thread will behave like a component of a string. Are you able to get me? मतलब इसको जैसे मतलब एक तरीका है कि सर इसको क्यों ही लफड़ा करें, पुली मासलेस है, पुली के पास फ्रिक्शन नहीं है तो उसके वजह से कुछ इफेक्ट आएगा क्या, नहीं ना. बस तो इसीलिए अपन ने क्या किया, उस स्ट्रिंग का ध्यान से देखो तो जितना लेंथ स्ट्रिंग में चेंज हो रहा है उतना ही लेंथ स्प्रिंग में भी चेंज हो रहा है, तो उस स्ट्रिंग को अपन ने स्प्रिंग की तरह ट्रीट कर लिया. इज दैट क्लियर? Okay, so that was our way to consider it in horizontal way, and the answer will be still same. T is equal to root under 2 pi root under. कोई मतलब नहीं था. Just कोई मतलब नहीं था. Is that clear? ऐसे ही डेकोरेशन कर रहा है. लेकिन अगले वाले क्वेश्चन में डेकोरेशन नहीं होगा पुली का. तब ध्यान से बस सोचो, बनाओ इस क्वेश्चन को बनाओ. अब मालूम चलेगा कि पुली डेकोरेट कर रहा है या पुली हेल्प कर रहा है. Once again, there is no mass on the pulley. ठीक है. यहाँ पे हरदम मासलेस ही बात करेंगे, रोटेशनल जब तक नहीं आएगा तब तक हम नहीं 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 नहीं, मास आ गया तो पुली रोटेट करना स्टार्ट कर देगी. पुली कुछ नहीं कर रही बेटा, पुली बस सीधा पड़ी हुई है ना. यहाँ पे सोचो सेम क्यों नहीं होगा. थिंक, बोल रहा है द फिगर shows consisting of a massless pulley already mentioned, the spring force of constant k, a block of mass m. If the block is slightly displaced from vertical down from its equilibrium position and then released, find the period of its vertical oscillation. Find the period of its vertical oscillation. Is that clear or not? सोचो, बहुत ही अच्छा क्वेश्चन है, मींस इट्स अ mesmerizing क्वेश्चन यू कैन से। या थिंक, आई एम नॉट अवेयर। यस, काइंड ऑफ। या लेट इट बी। ओके, no Riva, think once again, how come it will be half? Mm, 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 mm. Okay, one hint, this question will be solved using constant motion. Yeah, ठीक है, चलो बनाते हैं इसको, है ना? थोड़ा देखते हैं। अच्छा, एक बात होता है, थोड़ा let us just try to see, you just tell me one thing, if there is a pulley, okay, and let's suppose there is a thread attached with the center of the pulley. These are two threads, okay. Now let us just try to think one case. These are my two blocks of different masses. I'm not considering even the masses, okay. Okay, m1 m2 whatsoever it is। एक बात बताओ तुम्हें, अगर मान लो ये ब्लॉक नीचे जा रहा है, लेट्स सपोज इफ दिस ब्लॉक goes by distance x downwards, how much distance? This block will rise up by same distance x or not? Yes, but if it is goes down with some distance x, let's suppose this is block b, so velocity of block b is downwards, velocity of block a is upwards, are you able to get me or not? Then velocity of pulley, let's suppose I'm considering downwards, where it is, let us just make it upwards, let us just make it upwards, where it is upwards. So you know that the relation is given as velocity of pulley is equal to velocity of block a plus velocity of block, that's my constant relation or not? अब ध्यान से देखो जरा, if I can write the velocity equation, velocity is just the change in length per unit time or not. In mass m, the displacement, let's suppose velocity of a is upward, so displacement is where? Upwards, isn't it? Velocity of b is downwards, so the displacement is also where? Is that clear or not? Now that means divided by 2 must be equal to the displacement of my pulley or not. So what you get, if the both of the blocks are risen up and displaced by same distance, then the displacement in pulley is same. Displacement in the pulley is how much? It is same basically। कैसा रहेगा, हरदम सेम ही रहेगा। इज दैट क्लियर? बेसिकली अगर ध्यान से देखा जाए तो यहाँ पे दोनों एक दूसरे के सेम डायरेक्शन में है, तो अगर मैं ध्यान से देखूँ तो ये वैल्यू नेगेटिव होनी चाहिए। कैसी होनी चाहिए? सो बेसिकली दिस डिस्प्लेसमेंट इज हाउ मच? जीरो। अगर मान लो ये ब्लॉक सेम डिस्प्लेसमेंट चला, ये ब्लॉक सेम डिस्प्लेसमेंट चला, तो पुली कहीं भी डिस्प्लेस नहीं होगी, पुली विल नेवर एवर डिस्प्लेस। आर एबल टू गेट मी और नॉट? हटेगी ही नहीं। लेकिन इन प्रीवियस क्वेश्चन इन ओवर हियर द थिंग इज टोटली डिफरेंट, हियर इट इज फिक्स्ड और नॉट। So if let's suppose mass m goes, it travels by x naught distance to attain which point? Equilibrium point. Which point? X naught is displacement to attain equilibrium point. तो ध्यान से देखो जरा, अगर x naught equilibrium point attain करने की कोशिश करेगा, this displacement is how much? Zero basically. How much is that? So the pulley will be displaced. Then the pulley for the case of equilibrium will be displaced by some distance of x naught by 2 or not. Look over there. If this displacement is x and then this displacement is how much? 0. So displacement by pulley will be how much? X plus 0 divided by 2. How much is that? X by 2. Is that clear? मेरी बातें समझ में आई या नहीं है? So the displacement in the pulley is how much for the equilibrium case? For equilibrium is how much, guys? X naught by 2. Is that clear or not? तो ध्यान से देखो, अगर हम इक्वेशन लिखना चाहें तो दिस इज माय टेंशन टी फॉर द इक्विलिब्रियम केस, दिस विल बी टेंशन टी डाउनवर्ड्स विल बी mg, this will be also tension T in upward direction. There is no force over here, so no contact. So basically, on the upward direction, how much tension T will be present? Twice of T. How much will be present? 2T. Is that clear or not? So basically, if I can write for equilibrium I'm writing T naught is equal to how much? mg. For which point? The net force must be equal to, upward force must be equal to downward force for which point? Equilibrium point. मतलब यहाँ पर जो टेंशन है वो क्या जिसके बराबर है? हाँ, इज दैट क्लियर? तो बेसिकली अगर ध्यान से सोचो जरा, तो इफ आई displace by x naught distance, the spring is stretched by how much distance? X naught by, so basically k x naught by 2, then for this spring k x naught by 2 at the equilibrium point must be exactly equal to twice t or not for the equilibrium point. Is that clear? मेरी बातें समझ में आ रही हैं? This, since it is displaced by x naught by 2 and the upward force is 2t and the spring is not breaking, so k x naught by 2 must be exactly equal to how much? Twice t. So basically k x naught is equal to how much? Yeah, pulley is not, no no pulley, listen ध्यान से समझो। ये है स्प्रिंग पुली का नॉर्मल केस है ना, ठीक, इसको बड़ा बनाते हैं तब मजा आएगा देखने में, हाँ अच्छे से समझेंगे इसको, ऐसा नहीं है कि आसान क्वेश्चन है, बहुत अच्छे क्वेश्चंस मैं करा रहा हूँ तुम्हें। ये हो गया स्प्रिंग है ना, पुली, इसके साथ एक थ्रेड है, इसके साथ एक ब्लॉक है ना। तो पहला स्टेप क्या है? फर्स्ट स्टेप इज व्हाट? दिस स्प्रिंग विल गो टू इक्विलिब्रियम पॉइंट और नॉट? But the equilibrium point will be attained for what case? For the case of block, isn't it? So the pulley goes down. Okay. Pulley goes down. Let's suppose over here the block was displaced by how much distance? X naught. How much distance? Means this was its original position. This is my displacement from natural length, and this point is, yeah, this point is basically which point? Equilibrium point. So if this is x naught, then this pulley from here to here will be displaced by how much? X naught by 2. कितना displace होगा इस is that clear? Hmm. So now for equilibrium point, we know that tension T is equal to how much? Mg, but over here also tension T is present. So due to this expansion, the spring force which will be present must be exactly equal to kx naught by how much? 2. For which case? Equilibrium point. Which case? Equilibrium point. And this kx naught by 2 must be exactly equal to the two downward forces which are present on the pulley, which is 2t, or kx naught barabar how much? 4 mg, because t is equal to how much? Mg. Are you able to get me or not? So for equilibrium, kx naught is equal to how much? 4 times mg. Now you need to displace it further, isn't it? अभी हमें क्या करना है, इसको और आगे डिस्प्लेस करना है ना. हाउ मच आई हैव टू डिस्प्लेस? By some distance x. The next step is the same pulley block system. 1 minute. This is my pulley, this is my thing, and this block, 1 minute, wrong diagram. 1 2, okay, let us just bring this over here. So this block which was over there now has came over here. See that this is my equilibrium point, and from equilibrium point it has traveled how much distance? X. How much distance? X. So previously see, from natural length it has traveled x naught. Now how much it has traveled? तो ध्यान से देखो, अगर इसका हम स्प्रिंग का नेचुरल लेंथ बात करें तो पहले कितना चला? x naught by. Now it will travel by x by 2 or not? Yeah, so basically, if you write the force equation, upper is tension T, downwards is still my mg force. Are you able to get me or not? So basically, what will be equation? T is equal to how much once again? mg. मेरी बातें समझ में आ रही हैं? But this time, as it is trying to pull it down and down and down, let us just try to understand this equation in a much more great sense. That this spring force over here means this spring force over here is how much this time? K x naught by 2 plus how much? X by 2 or not? If you look into the pulley, the downward force is T, and for this, for the pulley block system, this is how much? T. Are you able to get me? So ध्यान से देखो तो बेसिकली एफ नेट का इक्वेशन क्या आएगा? 2t माइनस के एक्स नॉट बाई 2 माइनस एक्स बाई 2 और प्लस एक्स बाई 2. आर एबल टू गेट मी और नॉट? मेरी बातें समझ में आ रही है ना? Basically, for equilibrium point, what we know that tension acts opposite for the pulley system. So 2t must be equal to kx naught by 2. Then only it is at equilibrium point. But for F net, what is the equation? 2t minus kx naught by 2 plus x by 2. Is that clear or not? So basically, let's suppose when the block is displaced by distance x from equilibrium point, then the F net equation is given as 2t minus k x naught by 2 प्लस एक्स बाई 2. मेरी बातें समझ में आई या नहीं है? ठीक है, आगे बढ़ूं. तो इतना दूर क्लियर अगर तुम्हें समझ में आ गया, 2t अगर हम इक्वेशन लिखें तो basically what I will write that equation. T is basically exactly equal to how much? 1 minute, sorry. T is basically exactly equal to how much? Mg or not? So 2 mg minus 1 minute. I believe you can still write this in much more good way. Why to write in 2t? We can still write this in much more good way. Mm, Okay, 1 minute. I can write this equation for the block itself. That will make my question much more easy. ध्यान से देखो. I can write this F net equation for the mg block for the force of mg. Is that clear or not? So ध्यान से देखो. Can I write it as mg minus tension T for block, isn't it? ध्यान से देखो. After displacing from equilibrium point, the equation will be what? mg minus tension. But this tension T must be exactly equal to, since the pulley is massless, so this 2T must be equal to now the new spring force, which is K by 2 divided by X by 2, isn't it? So T is how much? K by 2 X naught by 2 plus X by 2. ये equation होगा या नहीं होगा? Because that makes our question too much easy. Are you able to get me or not? Previous way we'll have to replace too many variables. So F net can be written as how much? Mg minus T after the equilibrium point. This is Mg. And upward is tension T. This is also tension T. Now since if the pulley is massless, then the downward force of 2T must balance the spring force Fs. Is that clear or not? So F net is given as Mg minus K by 2 X naught by 2 plus X by 2. Are you able to get me or not? Now you see that that gives the correct approach, that provides us the correct answer. How? Try to understand. When we wrote this F net equation will change to F net is equal to mg minus kx naught by 4 minus kx by how much? 4. कितना हो जाएगा? ठीक है. अब ध्यान से देखो के एक्स नॉट की वैल्यू 4 mg के बराबर है या नहीं है, तो एफ नेट की वैल्यू देखो आसान हुआ या नहीं हुआ. तो एफ नेट इज इक्वल टू हाउ मच? mg माइनस mg कैंसिल kx बाई 4. कितना आया? तो ओमेगा स्क्वायर की वैल्यू है क्या? इसको हम लिख सकते हैं ना मास इनटू एक्सेलरेशन. चलो इसको फुल मैं लिख के दिखा दे रहा हूँ. आई कैन राइट दिस एज kx naught is equal to 4 mg from this equation or not? So minus ma is equal to minus of kx by 4. A is equal to minus of k by 4m into x. So ओमेगा स्क्वायर की वैल्यू क्या हो गई? k by 4m. और टाइम पीरियड क्या आया? 2 pi root under 4m by k. Is that clear or not? Okay. I'll just make you understand once again. Just try to first, just try to understand these equations and then I'll move ahead. Okay. Yeah, I'll definitely explain. Just try to digest it first of all. Okay. मतलब इस equations को बस. Okay. Okay. So let us just try to pick up this and then we'll once again. I'm just going to explain it once again and then we'll move ahead. ठीक है. देखो पहली बात, जब टाइम पीरियड इक्वेशन लिख रहे हो, व्हाट यू आर राइटिंग, इफ यू आर राइटिंग टाइम पीरियड इक्वेशन, कीप इन समथिंग इन माइंड दैट यू आर राइटिंग ब्लॉक इक्वेशन. क्या लिख रहे हो तुम? ठीक, ब्लॉक इक्वेशन. ब्लॉक इक्वेशन. Is that correct? Now, if I attach a spring with a pulley, with a thread, with a block of mass, which is at its natural length, कैसा length है ये? ठीक, अपन आगे ड्रॉ करते जाएंगे, है ना? अब मान लो इस मास m को अपन ने डिस्प्लेस करा दिया बाय सम अमाउंट, ठीक, ये पुली नीचे आ गई और ये मास m हैज बीन डिस्प्लेस्ड बाय सम अमाउंट x नॉट from the natural from the natural length to attain its equilibrium point. Which point? ठीक, थर्ड केस क्या है? तीन ग्राफ होंगे ना इसके. थर्ड केस I displace is furthermore and with respect to equilibrium point I travel much more little bit further distance, which is how much? X distance. कितना distance है ये? कितने ग्राफ आएंगे? तीन ग्राफ. कितने ग्राफ? नेचुरल लेंथ का, इक्विलिब्रियम पॉइंट और point. Is that clear? Now for the natural length, no equation. For equilibrium point, what will happen? Mg is downwards, tension T is upward. For the pulley, tension T is downward. For this pulley, tension T is downward and tension T is upwards. Is that clear? If this is x naught, then displacement in the pulley is how much? X naught by 2. Now, this displacement in x naught by 2 will generate a spring force or not? So, as the pulley is massless and pulley is not accelerating, so upward force must be equal to downward force of the pulley. So, for equilibrium point, I get spring force is equal to how much? Twice T. कितना आएगा? स्प्रिंग फोर्स होगा क्या? kx नॉट by 2 due to the expansion must be equal to twice t और kx नॉट बराबर how much? 4t or not? Now, if this is a equilibrium point, yeah, so kx नॉट बराबर how much? 4 mg, because it is a which kind of point? Equilibrium point. Are you able to get me? Now I displaced it further more. अब मैंने इसको further more displace किया mg की वजह से. तो अभी क्या होगा? mg अभी डोमिनेट कर रहा है नहीं कर रहा? कर रहा है ना. तो जो इक्वेशन आएगा एफ नेट का वो क्या होगा? एफ नेट बराबर mg माइनस टेंशन टी. अब ये टी कौन सा होगा? ये टी न्यू होगा यानी टी डैश होगा ना, क्योंकि ये तो नया टेंशन है. We'll talk about that. This T dash is a new tension or not? It is. So there, because upward is an spring force attached. Spring is there. Okay. So this is, let's suppose T dash. This is also T dash. This is also how much? T dash. But if it is displaced by x, equilibrium point was displaced by x naught. So total displacement in the spring will be x naught by 2 plus x by 2. Once again, spring is this pulley is still massless. So the upward force of the spring force nu must be equal to 2t dash or not? Must be equal to how much? 2t. Spring force nu is how much? K. X naught by 2 plus x by 2 must be equal to 2t dash. Are you able to get me or not? Now, here the mg force is predominating. So F net is equal to how much? Mg minus tension T dash. Replace it over here. You get the equation. Are you able to get me? Understood. So that's what I did earlier. That's what I did earlier. Replacing mg minus t, which is mg minus k by 2, x naught by 2 plus x by 2, which gives me omega. That is t is equal to 2 pi root under 4 m by k. Are you able to get me or not? Is that clear? मेरी बातें समझ में आई? Totally clear or not? ठीक है, आगे बढ़े. आगे बढ़ा जाए. प्रीवियस वाला उसमें क्या था? उसमें उसमें स्प्रिंग लेंथ सेम रहता था ना, इसमें लेंथ क्या अलग अलग है ना, इसमें फिक्स्ड पुली है, इसमें किस तरह का पुली है, so length is not changing, but over there this is a movable pulley, so length is changing. Okay, so let us just try this equation once again for one more case and then we'll move ahead. Just try this question. Think. This is also easy, too much easy. Yeah, so no problem. The length of the thread should be always constant. So pulley will come vertically downwards only. Follow these steps, then you will get the answer definitely. Yes, correct, Riva. Riva have done it. Bana, Srishti, is it done? अच्छा पहले ये बताओ, इसके तीन डायग्राम होंगे या नहीं होंगे, तीन डायग्राम होंगे ना, तीनों डायग्राम तुमने ड्रॉ किया पहले। देखो पहले अगर मान लो इसका डायग्राम ड्रॉ करते हैं ना, लेट अस जस्ट ड्रॉ दिस डायग्राम। ओके, सॉरी, ठीक, yeah, this pulley will go down, isn't it, to have the equilibrium point of mass m, isn't it? So let's suppose mass m travels by how much distance? X naught, to have the equilibrium point. Which point? अब मान लो अगर ये x नॉट है तो इधर का एक्सपेंशन जो होगा वो x नॉट बाई टू होना चाहिए ना, है ना, यही होना चाहिए। हमें मालूम है v ऑफ पुली इज इक्वल टू v ऑफ a प्लस v ऑफ b डिवाइड बाई टू। अब v ऑफ a और v ऑफ b दोनों सेम होने वाला है, तो v ऑफ पुली इज इफ, oh 1 minute, sorry, 1 minute, it's not x naught by 2, it is how much, twice of x naught. How much is that? Look over there, this point is fixed or not, its velocity is how much, 0, so v of b, मान लो ये v of b है, divided by 2. So V of B is equal to twice of V of pulley. That means अगर pulley x naught distance चला, the spring will be traveling how much distance? Twice of x naught. How much it need to be traveling? Look over here. This pulley has some velocity downwards. This velocity is 0. This is V of B. So if V of P is equal to 0 plus V of B, so V of B is equal to, if pulley travels by x naught distance, B must need to be traveled by how much distance? Twice of x naught. Is that clear or not? So ध्यान से देखो, तो अगर मान लो if pulley travels by x naught, the block, this spring travels by how much? Twice of x naught. Is that clear? This is my equilibrium point. This is my mg. Let us consider that the tension present over here is T. How much is the tension present? So for equilibrium point, tension T is equal to how much? Equilibrium. I'm writing for equilibrium point. Which case? Yeah. So tension T is equal to how much? mg. Are you able to get me or not? अब मान लो this is tension T. That must be equally divided into these two parts or not? Tension T. Isn't it? या और एक बात बताओ, तुम्हें पहले ही बोला है कि जो स्प्रिंग फोर्स होता है बेटा, वो सिमिलर टू कांटेक्ट फोर्स होता है नहीं होता? तो स्प्रिंग फोर्स इज सिमिलर टू टेंशन फोर्स ओनली और नॉट? सो स्प्रिंग फोर्स, दिस मींस फॉर इक्विलिब्रियम पॉइंट ट्वाइस ऑफ स्प्रिंग फोर्स मस्ट बी इक्वल टू टेंशन टी. आर एबल टू गेट मी और नॉट? ट्वाइस ऑफ स्प्रिंग फोर्स मींस ट्वाइस ऑफ, ध्यान से देखो एक्सपेंशन कितना है स्प्रिंग फोर्स में? ट्वाइस ऑफ एक्स नॉट, 2 k x नॉट बराबर टेंशन टी, और के एक्स नॉट बराबर हाउ मच? टी बाई 4. कितना आया? मेरी बातें समझ में आई? मेरी बातें समझ में आई है ना? ठीक. तो अपन को के एक्स नॉट की वैल्यू मिल गई. अब हम इसको थोड़ा और डिस्प्लेस करेंगे. थर्ड एक्सपेंशन, मान लो डिस्प्लेसमेंट कितना हुआ? एक्स का. कितना का हुआ? तो इसमें 2x ऐड होगा या नहीं होगा? अब टेंशन बदल जाएगी ना, तो नेट फोर्स का इक्वेशन क्या आएगा? mg माइनस टेंशन टी डैश. क्या आ जाएगा? यस. एंड मतलब ये बात समझ में आ रही है ना? ध्यान से देखो, मैं फिर से बता दे रहा हूँ. स्प्रिंग थ्रेड expanded more, pulley has came down with mass m. This was my x naught, now it is x distance away. So this was originally x naught, twice of x naught. Now it is twice of x. So the tension, the downward force is still mg, but the tension is new. Tension कैसा हो जाएगा? New. तो नीचे का टेंशन क्या आया? टी डैश. स्प्रिंग फोर्स भी तो चेंज हो जाएगा ना. स्प्रिंग फोर्स विल बी एफ एस डैश, और यहाँ पे भी एफ एस डैश. आर एबल टू गेट मी और नॉट? तो ट्वाइस ऑफ एफ एस डैश मस्ट बी इक्वल टू टेंशन टी डैश, एंड टेंशन टी डैश, सॉरी नेट फोर्स इक्वेशन क्या आएगा? mg माइनस टी डैश. इक्वेशन पुट कर दो. mg minus twice of fs dash, that's my f net equation. और क्या आएगा? mg minus twice fs dash कितना है बेटा? k of twice of x naught plus twice of x. Are you able to get me or not? So the equation will change to what? F net is equal to mg minus 4kx naught plus, sorry, minus 4kx. ध्यान से देखो, के एक्स नॉट बराबर हाउ मच? टी बाई 4, विच इज एम जी बाई 4. एट इक्विलिब्रियम पॉइंट टेंशन टी इज इक्वल टू हाउ मच? एम जी. आर यू एबल टू गेट मी? सो रिप्लेस इट ओवर हियर. एफ नेट एम जी माइनस एम जी आ जाएगा माइनस, सॉरी यहाँ पे 4 से मल्टीप्लाई होगा, 4 के एक्स. तो एफ नेट क्या आया बेटा? माइनस 4 के एक्स. है कि नहीं? है कि नहीं? तो ध्यान से देखो, देयर इक्वेशन क्या बना तुम्हारे पास? मास इंटू एक्सेलरेशन इज इक्वल टू माइनस फोर के एक्स, और एक्सेलरेशन इज इक्वल टू माइनस फोर के बाई एम इंटू एक्स, और टाइम पीरियड क्या बन जाएगा फिर? टू पाई एम बाई फोर के. आर एबल टू गेट मी और नॉट? इज दिस क्लियर? So this is how you write the time period equation. In previous equation it was 2 pi 4m by k. इस बार क्या हो गया? चेंज हो गया. इस बार क्या आएगा? mg by 4. So you have to remember the step. First step is no equilibrium. Then equilibrium, write the equation. Then with the extended length write the equation. Write all the equations for the block. You'll get the answer. Is that clear or not? So this was all about how you write the time period equations. Now there are more questions which we will do almost tomorrow. Is that clear or not? Okay, we'll do on Friday. Okay. मजा आया? समझ में आया कॉन्सेप्ट? ओके ओके.